In this presentation, we'd like to discuss the subject of climate change. Broadly speaking, climate changes all the time. Over the last 10,000 years, we've seen temperature fluctuations of 3 to 5 degrees centigrade. More specifically, we'd like to discuss the subject of anthropogenic climate change, the claim that human activity is influencing the climate of the planet. The popular narrative goes something like this: humans burn fossil fuels. Fossil fuels release carbon dioxide into the atmosphere. Carbon dioxide is a greenhouse gas, meaning it absorbs infrared radiation. This CO2 absorption drives up the temperature of the atmosphere, and this increase in the temperature of the atmosphere leads to catastrophe. So, first things first, are humans burning fossil fuels? Yes, indeed. In fact, commencing in about the 1940s, our consumption of fossil fuels has accelerated dramatically. Secondly, does burning fossil fuels increase the concentration of carbon dioxide in the atmosphere? Yes, indeed. To the best of our information, we've gone up by maybe 30 or more % over the last 50 years or so. We're in the 420 parts per million range. Number 3, is carbon dioxide a greenhouse gas? Yes, in fact, it absorbs quite strongly in the infrared, particularly at about 4.3 and 14.9 microns. Does this increase in carbon dioxide in the atmosphere drive up the temperature of the atmosphere? That's a little less obvious. Well, from an historical perspective, I think we can say no. Although there seems to be a pretty strong correlation between carbon dioxide and temperature, we note that changes in temperature occur first, followed then by changes in the carbon dioxide concentration. So from that, we conclude that carbon dioxide can't be a driver of temperature, at least over the historical record. But what about more recently? Although we have seen an increase in temperature in the atmosphere commencing in about the 1980s, there doesn't seem to be a clear correlation with this burgeoning consumption of fossil fuels and what is a fairly dramatic rise in the carbon dioxide concentration. Since we've noted the increase in temperature since the 1980s, I think we'd be scientifically remiss if we didn't notice the temperature decrease between the period of 1930 and 1980. For those of us who were alive and sentient during the 70s, the great climate scare at that time was that the Earth was headed toward a new ice age. I'm not exaggerating when I say that the projections said that New York was going to be under a mile of ice within just the next few decades. So it behooves us to be cautious about overreacting to what amount to short-term trends in the atmospheric temperature. So if we have both cooling and warming trends over the course of a century or two, then what's driving that? In fact, as shown in this graph, temperature fluctuations correlate very well with solar activity and don't correlate very well at all with the consumption of fossil fuels. Here's another data set illustrating the same thing. In fact, temperature fluctuations correlate very well with total solar irradiance and don't seem to correlate very well at all with fossil fuel consumption. So how is it that we can have carbon dioxide, a pretty strong greenhouse gas, increasing in the atmosphere, and yet not have CO2 as a driver in atmospheric temperature? If we take a closer look at the absorption spectrum of the atmosphere, we can see that that absorption is already saturated where carbon dioxide absorbs. So it's kind of like shining a flashlight on a piece of black construction paper and concerning ourselves with the thickness of that black construction paper. It doesn't make any difference because all the light is already absorbed where carbon dioxide is active. Now, to be fair, that linear analogy is an oversimplification. A better analogy would be shining a flashlight through a dense fog in which all the light is absorbed in the first, let's say, 100 feet, and then increasing the density of that fog. Now, you wouldn't be absorbing more energy, but you would be putting the energy in a slightly different place, in this case closer to the flashlight. But it is true that now we're talking about secondary and tertiary effects, and it does seem more likely that a first order effect, like total solar irradiance, would have a more pronounced effect on the environment than a secondary or tertiary effect of a small contribution like CO2 absorption. But putting that aside for a minute, let's take a look at the empirical evidence for the actual effect on the climate. Let's take a look at number 5. An increase in the temperature of the atmosphere leads to catastrophe. Some of the top 4 commonly cited indications of anthropogenic climate change are number 1, sea levels rising, number 2, glaciers melting, number 3, polar ice melting, and number 4, weather becoming less stable and more severe. 3 examples of that are hurricanes increasing in severity, droughts more severe and protracted, and wildfires more frequent and damaging. I just want to make a note here. This topic is frequently emotional for many people. I have an adage that there are 2 forms of human communication, math and BS. So when we discuss this, we're discussing the data, not the person, not the feelings about the data. Now I'd like to make note of where the data for this presentation originates. Most of it comes from the NOAA website, the website of the National Oceanic and Atmospheric Administration. I provided 4 sublinks here because it can be a little bit difficult to navigate unless you know what you're looking for. I would also caution the visitor to the NOAA website to focus on the data and not the words. Scientists can have biases like anyone else, and this can be an emotional and politically charged topic for many. Additionally, there is an excellent paper on the environmental effects of increase in carbon dioxide. It was published in the Journal of the American Physicians and Surgeons in 2007, and I consider it to be one of the best and most objective treatments on the subject. First, let's look at the data concerning the claim of sea level rise. We'll look at data on sea level rise for 8 cities around the world, and then we'll look at the more general trends. I'm looking at a graph here of the sea level in Honolulu, Hawaii. Although it does show a gradual increase, that rate of change has not altered over the period of time that our consumption of fossil fuels has accelerated dramatically. The rate of change here is about 6 inches per century, but it has remained at that rate over the last 120 years. Again, there seems to have been no effect on that sea level rise in Honolulu, Hawaii over the last 110 years as a result of fossil fuel consumption. Here's a plot of the data from Juneau, Alaska. This is a little bit of an anomaly because the sea level seems to actually be decreasing at a rate of about 4 feet per 100 years. But again, no change over the last 80 years. Marseille, France. Data since the late 1800s. Average increase in sea level of about 5 inches per 100 years. But again, no change over the period of that time. There's been no acceleration of the sea level rise, and there's no correlation with this data to the consumption of fossil fuels. San Francisco, California. A little bit of a glitch at around the 1900 range. But again, 0.64 feet per 100 years, and that rate has not changed since 1850. No correlation to the consumption of fossil fuels. Reykjavik, Iceland, data since 1960. Average rate of 0.77 feet per 100 years, and if anything, it's leveled off in the last 20 years or so. Most certainly, and again, no correlation to the consumption of fossil fuels. Stockholm, Sweden. Sea level dropping at about 1.25 feet per 100 years since 1890. And again, no change over the period of that time and no correlation to the consumption of fossil fuels. Tuapse, Russia. Data since 1920. Sea level increasing by about 0.8 feet per 100 years. No change over the period of that time. Venice, Italy. Data since about 1870. Rise rate of about 10 inches per century. And again, no change over the last, moving on a century and a half. Here's a useful figure that shows the entire United States in one snapshot. sea level rise rates are color-coded, and the average is somewhere in the 7 inches per century range. Here's a useful plot that shows the global sea level measured by surface gauges between 1807 and 2002, plotted against the rate of fossil fuel consumption. Again, the sea level rises about 7 inches per century since about 1850, and has continued at that rate without change during the period of time that our consumption of fossil fuels has accelerated. Here's a similar plot that illustrates a similar conclusion for glacier shortening. The 180-year trend has continued unchanged during the period of time that our fossil fuel consumption has increased. How about polar ice melting? Does a rise in carbon dioxide and temperatures cause polar ice to melt? Well, here's a plot of Arctic sea ice extent. In fact, it does seem to be dropping. So with all this ice melting, and in particular the glacial ice melting, why haven't we seen any sea level rise? What about this claim that if we lose all of our polar ice, the sea level will rise by 200 feet? That calculation is based on the entirety of the southern polar ice cap melting. So what's the status of the Antarctic sea ice? Antarctic sea ice is actually growing. Over the period of the last 35 or 40 years, the general trend has been that we've had more Antarctic sea ice than the previous year. By that argument, maybe we should be worried about the Antarctic sea ice taking over the world. At this point, we've taken a look at the data concerning sea level rise, glacier melt rates, and polar ice cap melt rates, and there doesn't seem to be any veracity to the alarmist claim that the climate is changing significantly. Let's take a look at our fourth category. Rise in carbon dioxide and temperatures cause weather to become less stable and more severe. Particularly, let's look at hurricanes. Well, according to the data, there's been no increase in the maximum hurricane wind speed or the number of violent Atlantic hurricanes over the last 80 or so years. But let's look at that a little more closely. The number of hurricanes isn't actually a very good measure of the weather. For instance, you might have the same number of Category 1 hurricanes or Category 5 hurricanes, in which case you'd have a very different atmospheric condition. So let's look at the number of hurricanes broken down by category. Still no change. The number of major storms, that is Category 3, 4, and 5, hasn't changed over the last century and a half, nor has the number of hurricanes in total. But let's look at that still more closely, because that still doesn't tell the whole story. For instance, if you had a Category 3 hurricane that lasted for a day versus a Category 3 hurricane that lasted for a month, you'd still have a very different atmospheric condition. The number sums to something called the accumulated cyclone energy, which takes into account the number of storms, the intensity of those storms, and the duration of those storms. And how has that evolved over the last 150 years? Yes, you guessed it, flat as a board. Again, there's been no change to the yearly accumulated cyclone energy, which takes into account the number of storms, the intensity of those storms, and the duration of those storms. And there's been no change to that number over the last 150 years. Well, let's take a look at our second category, droughts becoming more severe and protracted. Well, here's a plot of the Palmer Drought Severity Index for the 48 contiguous United States between 1895 and 2011. I think we can tell that there has been really no detectable change over that period of time. And again, not over the period of time that our consumption of fossil fuels has increased dramatically. Let's take a look at a specific example. Here's a plot of the total precipitation in the state of California over the last 120 years or so. I think we can agree there's been no substantive change over the period of that time. There's been a lot of news over the past decade or so about wildfires in California. Wildfires are indeed a tragedy and cause a great deal of property damage and death. And it looks by this data that over the last 30 or so years, the acreage burned in California by wildfires is going up. One might be tempted to conclude that this has to do with climate change. But a more thorough look at the data reveals quite a different story. It seems indeed that the trouble we're having with wildfires these days has everything to do with forest management and nothing to do with climate change. We would argue that a careful review of the data reveals very little support to the notion of anthropogenic climate change. Indeed, humans are burning fossil fuels. Indeed, fossil fuels do release carbon dioxide into the atmosphere, and indeed, carbon dioxide is a greenhouse gas. But there doesn't seem to be any support to the assertion that an increase in the level of carbon dioxide in the atmosphere is giving rise to sea level changes, glacier melting, polar ice caps melting, or any instability in the weather. In closing, I would like to offer that I do believe that the term settled science is an oxymoron. In any science book I've ever seen, I have never seen it described as the fact of gravity or the atomic facts. These are offered as the atomic theory and the theory of gravity. Science uses these terms purposefully to invite challenge and revision. Challenge, revision, and open-mindedness promote advancement and understanding.